Hello, my dear students. Today we are going to discuss another numerical problem related to the clutch. This is the numerical problem of clutch. A single dry plate clutch transmits 7.5 kilowatt at 900 rpm. The axial pressure is limited to 0.07 Newton per mm square. If the coefficient of friction is 0.25, find number one, the mean radius and face width of the friction lining, assuming the ratio of mean radius to the face width as 4. And second one is outer and inner radii of friction plates or clutch plates. So here you can see that we have to calculate the mean radius, that is capital R, and the face width, that is small b. And the ratio of capital R and small b, that is equals to 4, is given in the question. And also we have to calculate the outer and inner radius, that it means R1 and R2. And the given data is 7.5 kilowatt, that is power. P is equals to 7.5 kilowatt, and at 900 rpm, that means speed capital N is equals to 900 rpm. This is the axial pressure, that P is equals to 0.07 Newton per mm square, and coefficient of friction, that is mu, is equals to 0.25. So this is the given data. So we will start from the given data. All the given data are written here, and N is equals to 2 for single plate clutch. And we have to calculate the mean radius, face width, and outer and inner radius, R1 and R2. So we will start from the given. In the given data, the power is given. So we know that the power transmitted by the clutch, P is equals to 2 pi nt upon 60. So this is the equation. P is equals to 2 pi nt upon 60. So here we know that this is torque transmitted by the clutch. So from this equation, we will have the value of torque transmitted by the clutch, because we have the value of P. In the given data, you can see the 7.5 into 10 to the power 3 watt. So P is equals to this. And second one is pi is equals to 3.14. And third one is N, capital N, that is equals to 900 rpm. The only unknown is capital T, torque transmitted by the clutch. So T is equals to, what is the value of T? After solving this equation, we will have the value of torque transmitted by the clutch. This is the torque transmitted by clutch. And we know that the area of friction faces A is equals to 2 pi RB in terms of face width. And the axial force acting on the friction faces, that means W equals to pressure into area. The load is equals to pressure into area, or we can see that axial force acting on the surfaces or friction faces, W equals to P into A, and area of A is equals to 2 pi RB. So substituted here. And now torque transmitted by the clutch, T is equals to N mu WR. We already know that, and we are already using this formula many times, N mu WR. So here you can see the N is equals to 2. You can it is given in the given data. Mu is equals to 0.25, and W equals to this P 2 pi RB. So P is equals to 0.07, pi is equals to 3.14, or we have to calculate B. V is equals to, from this, B is equals to R by 4. So we have to substitute R by 4 here. This is only the equation in terms of capital R. So we have to put W in place of torque in the equation torque transmitted by the clutch. So here only one unknown in this equation, that is capital R. So we have the value of capital R after solving this equation. The capital R is equals to 113 mm. Now we have to substitute this value of capital R, that is mean radius, in this equation. So we will have the value of face width V. This is the value of B, 28.25 mm. Now we have to calculate R1 and R2. So R1 outer radius and inner radius. So we know that from the figure, we have already discussed at the time of derivation, face width V is equals to R1 minus R2. And we know that for uniform beer theory, the mean radius capital R, that is equals to R1 plus R2 by 2. We know that R1 plus R2 divided by 2. So now we have the value of B and capital R. But we have only two unknowns, that is R1 and R2. Two unknowns and two equations. So we easily we can calculate the value of R1 and R2 by these two equations, by solving these two equations. R1 value of R1 and R2, that is equals to this. So this is the numerical problem and all the answers. So thank you very much.